Another form of symbolic diagram plan sheets is the P&ID drawing. So I'm going, just in case didn't really understand what I said, I'm going to here. That is P&ID drawing. It's used in most process applications. Electrical uses it a lot. It has many uses but it's very misunderstood and also misapplied frequently. We're going to learn a little bit about it and discuss some of the symbols. There's a whole network of symbols that mean particular things. So P&ID drawing. So what does that stand for? It stands for process and instrument diagram. And where would we use a P&ID drawing? That is similar to the flow diagram that we discussed in the last video. It describes the process with all of the particular equipment that is simplified and not cluttered with all of the actual dimensions, and whether it's a 6-inch pipe, a 4-inch pipe, so forth. We're getting rid of all of that, and we're symbolically looking at a process. Okay, typically a couple of things on process diagrams. Typically, when I say flow, I'm going to use the word flow loosely. That is how it reads. It reads just like a book. So we start at the top left and work our way to the right. It may or may not loop back around, but we go left to right. Up and down is the way that we read a P&ID, or we draw a P&ID, or so forth. So that's important that we understand that there's a direction. We saw this last video, and I'm going to zoom in a little bit. We have a symbol for a valve here. Here is another one, and here's another one. We talked about anytime you see the double triangles pointed together, that's a valve. It essentially necks down the flow. We're going to define it a little bit further here. Got the two triangles and then the circle in the middle. This is a ball valve, and it's just a style of valve. You have gate valves, ball valves, butterfly valves, just a whole gamut of different type of valves. But symbolically, with having the circle in there, that everybody knows that's a ball valve. It's a standard symbol. Another thing that's unique to process diagrams is each item has a label to it. It's a unique identifier. In this case, that's ball valve 116. Here's ball valve 112, ball valve 108. So you always include the label above it. I'm not going to get into too much information on these. These are sensors. This is actually a flow meter, but they have tags on them as well. So this is flow sensor, flow indicator. FI means flow indicator 101, flow transducer 101, and this is what this is trying to accomplish. So reading this from left to right, we have the supply that comes in, goes past the ball valve. It's going this way. We have a pressure indicator, fancy way of saying a pressure gauge. We have a 3-inch by 1/4 inch reducer, and then the flow can go either this way or it can go this way, and it's controlled by these two ball valves about which way it goes. So it will go through one of these two flow meters and then come back together. And then travel this way. As it travels, there's a T here, and this is a injection point with another ball valve. This particular symbol is a check valve, and it points the direction that it needs to go. Still going this way. We have a check valve here, ball valve here, and a reducer. And then at this point, we have 3 different ways we can go. Here, all controlled by ball valves, and this is a set of pumps. It's a triplex pump system. This is pretty much the symbol for a pump. And there's different types of pumps, but this indicates the pump. Notice the arrows that indicate which way the flow is. We know it's running left or right, but it is going that way. All right, so once it goes to the pump, it comes back together here and goes out here. It's going to go through this particular piece of equipment here. We don't know any information on it, so it's boxed in, and then go through the rest of them. We said this symbol is a check valve. This symbol is a ball valve. This symbol here is a valve. Remember, we said 2 triangles pointed together as a valve. We got this thing here. That's actually a pressure reduction valve, a pressure reducing valve. It regulates pressure. We have 2 triangles here, back to backs. It is with no circles, so it's not a ball valve. It's another type of valve, and with these circles on there, it indicates that they're motorized. So this is kind of the extent of a process process diagram. Anytime there's a change in pipe, we put reducers, or either we label the pipe. Size here, we indicate what it is. Notice a couple of things on here. There's not any call outs or leaders. We put boxes or indicate through symbols what the particular little piece of the puzzle is. Also, let's discuss a couple of things here. It not scaled. Okay, this is a diagrammatic display. Reads left to right, top to bottom. Has standardized symbols. Features tags or identifiers. Those are the numbers. that you see through here, even though the symbols repeat, there's multiple valves, each one of them is uniquely numbered. So you have to do that as well. If there is a crossing with no junction, use the crossover symbol. So what does that mean? If we have a line that meets, for instance here, delete this. For instance, if we have this here, we got this line meeting with this line, that means that's a T. Everything is connected together. And if we have a line running this way and a line running this way, that means that all four of these are joined together. So it's a cross. So all of those are hydraulically, electrically, some way they're all connected together. If this line just crosses over or under, then we need to show it accordingly. It doesn't need to be joined together. We do this with this particular symbol here. So this line here is not connected to this line here. We got this little jump over symbol here that tells us that they're not physically connected together. And again, this is a diagram, so these are not representative of any scales or size or anything. They are just pointing you to how the system operates. We will be doing a kind of a exercise on P&ID, so make sure you understand what they do mean.